Hi, everybody. This is the first of a series of three short lectures on Phanerozoic climate, the climate change and evolutionary changes over the last 550 million years. This is just a tiny fraction of the history of life on Earth, and yet it's a much more gigantic section of the Earth's history than we were talking about previously when we discussed recent ice ages. The Ice Age period of Earth's recent history was just the last 3 million years. Today, we're going to be looking at a span of time of 550 million years, more than 100 times as long. And yet, the Earth's overall history is 4.5 billion years old. And so, in our next class, after this one, we're going to be discussing deep time going back through the entire history of the Earth. I'm taking increasingly long sort of telescopic looks at the Earth's history going farther and farther back in time. But the period of the Phanerozoic, the last 550 million years, is really about the evolution and development of complicated life, things more than just a single cell. And so that's going to be our focus on the interaction between climate and life over this fascinating and dynamic time period. Now, there are many drivers for climate change during this period, and one of the ones that I want to emphasize is plate tectonics and continental drift. So you can see in this animation, the period we're interested in is Paleozoic, Mesozoic, and Cenozoic, and the continents were moving around throughout this entire period, joining up, breaking up, and so on, changing the amount of coastline that existed, the ability of rainfall to penetrate into the continents, volcanic eruptions during this time, and so on, all of which were leading to climate change. Just to back up again, the basic periods within this section of time are Paleozoic, which means old life, the Mesozoic, which means middle life, and the Cenozoic, which means modern life. Each of these periods were interrupted by big changes in life on Earth, which we'll talk about. But first, I want to set the stage for the overall climate change that was happening this time. So we have evidence from proxies, in particular oxygen isotope records, about what climate was doing over this time period. So the scale bar on the right-hand side is all about oxygen 18, which I talked about before as being a proxy for overall warmth and cold of the climate. And so we don't exactly know what the temperature was at any of these times, but we know that it was generally hot at this time and cold during this time. The last tens of millions of years have been relatively cold on the grand scheme of things. And most of Earth's past history during this time was much warmer than it is today. Ice ages were relatively few and far between, but there were some glacial periods during this time. We can take a closer up and more detailed view of, colder, warmer, and that sort of thing. So I want to focus specifically on the time from 500 million years, 550 to today. And you can see one major ice age during about 250, one and a major ice age that's the entire time period that we've been occupying now, that we talked about on Wednesday. Anyway, so climate was warming and cooling, but generally much warmer than it is today, with a couple of interesting exceptions. So what was going on with life during that time? Just before the beginning of this period, life was simple single-celled organisms. There was all bacteria and single-celled algae, but nothing you could pick up and eat. And that all changed at a period called the Cambrian explosion, which is what I'm going to be talking about next. Just before the Cambrian explosion, there was the first hints of multicellular organisms. We see fossil records of little, maybe sort of feather-shaped things with some sort of attachment points to a rock. These are definitely some sort of organism, but it's hard to tell what. This thing almost looks like a sand dollar, but it's definitely not. We really don't know what these organisms were. We're pretty sure they were animals and not plants, but it's hard to tell. It's tough to tell how they made a living, probably by filter feeding, but it's not exactly clear. These Ediacaran fauna from the 570 or so million years ago, it's a big mystery. We don't know what they are or how they work. It doesn't stop people from making artist impressions of what these organisms might have looked like, though. And you should definitely take pictures like this with a gigantic grain of salt. But all life at this point was in the oceans and was very simple in body plan and kind of a mystery about how it worked. And none of it really looked anything like organisms today. That all changed at a dramatic event that happened about 540 million years ago, at the very start of our time period today. This time period was called the Cambrian explosion. And within just a couple of million years, every single major group of animals that we know today, plus a bunch that don't exist anymore, suddenly appeared as obvious fossils all at once. Something happened in evolutionary history where life decided to suddenly say, let's be more than just a single cell. It's really hard to say why. And we're not exactly sure whether what happened here was a sudden change in the way life decided to organize itself, or perhaps these organisms had existed for millions of years before this, but during the Cambrian explosion, there was some sort of change in ocean chemistry that allowed them to become to grow bones and shells and kind of hard materials that would be preserved in rocks. And so maybe they existed for millions of years before that, but they all rotted and decayed away, and we didn't see them until the Cambrian. It's not exactly clear, but here's a snail-looking thing. It's an ammonite. Here's a trilobite-looking thing, crab-looking thing. It's a trilobite. And this, if you look carefully, has a backbone of sorts. It's an early vertebrate. It's one of your most distant ancestors. Say hi. So yes, all the major groups of animals suddenly appeared all at once within the oceans within a few million years of the Cambrian explosion. The time after that was a period of great diversification and the creation of lots and lots of different kinds of body plans in life. And this pattern continued for a couple 100 million years after that. Life was large, complicated, diverse ecosystems and food webs, and almost entirely in the ocean. Here's a picture of the organisms that might have existed during the Cambrian period, after the Cambrian explosion, about 500 million years ago. There are things like sponges and sea anemones. There are things like crabs. There are gigantic hunting predators that ate all kinds of stuff. There are also the first fish. This was a long period, lasting a couple of 100 million years. Maybe 60, 70 million years later, this is a picture of the Silurian period. Different kinds of life. This is a armored fish. This is a orthoceras, which is like a squid in a cone-shaped shell. Ammonites are still around. There's a big hunting predator in the background. These guys are crinoids. Anyway, complicated, diverse changes in life, but all in the ocean. What I'm going to talk about next is the extinctions. All right. This kind of diversification didn't last forever, and a series of dramatic climate change events brought this to a close, but also opened the way for the kinds of more complicated plants and animals that we see today. So